Hello, you are welcome. Today we're going to evaluate this definite integral, and this is Berkeley Math Tournament, right? Here we have this integral as x goes from 0 to 1 of x squared divided by 1 plus root of 1 minus x squared dx. And the most interesting part of this video is that I'm not gonna use trigonometric substitution. Here we're going to do it algebraically. Now let's get into the video. From here, we're going to rationalize, and we're going to multiply the numerator and the denominator by the conjugate form of the denominator. So we need to know that the conjugate form of the denominator 1 plus root of 1 minus x squared will be equal to 1 minus root of 1 minus x squared, right? Now let's go ahead and multiply the numerator and the denominator by the conjugate, right? So let's call this integral I. So here we're going to have that I will be equal to the integral from 0 to 1, then x squared multiplied by the conjugate form of the denominator, that is 1 minus square root of 1 minus x squared, then divided by the denominator 1 plus square root of 1 minus x squared multiplied by the conjugate 1 minus square root of 1 minus x squared. Then we have here dx, right? Now, carefully looking at this product here, we're going to see that this is just the difference of two squares, right? Take note of this. A plus B multiplied by A minus B is equal to A squared minus B squared. So here, we can see we have plus here and we have minus here in between these two variables A and B. And right over here we have plus and we have minus, so we're going to make use of the difference of two squares formula. So here our integral is equal to I, and that will be equal to the integral from 0 to 1. We have here x squared multiplied by 1 minus root of 1 minus x squared. Then here we're going to make use of this difference of two squares formula, and here we get 1 squared minus then root of 1 minus x squared then squared. Do not forget our dx, right? So we observe that this square here, we cancel this root sign, and here we have this equals integral from 0 to 1 of x squared into bracket 1 minus root of 1 minus x squared, then divided by, that would be 1 squared is 1, then minus, in bracket what we have there is 1 minus x squared, then we have dx. So here we have I is equal to the integral from 0 to 1, so we have x squared into bracket 1 minus root of 1 minus x squared, then divided by, here take note of this, this is 1 minus 1 plus x squared, right? That is from here, and which simplifies to just x squared. So down here we have x squared left and dx. So we have this nice cancellation that this and this will cancel out. So we have this equals the integral from 0 to 1 of 1 minus root of 1 minus x squared dx. Isn't that not amazing? Yes, of course. So we can see we have arrived at this interesting part of this integral here. Okay, so here let's split. So we have here our I will be equal to the integral from 0 to 1 of this one right over here, then dx, minus the integral from 0 to 1 of square root of 1 minus x squared dx. So here the integral of a constant with respect to x is x, right? So here that is a constant 1. Let's say this is 1, right? So this will be 1 times x, which is x. For example, assuming we have the integral from 0 to 1 of 2 dx. Remember, the integral of 2 with respect to x will be 2 times x. So here, that will be x. That is 1 times x, which is x. And we have our limits running from 0 to 1. And here we have minus the integral from 0 to 1 of square root of 1 minus x squared dx. So obviously, this place is equal to 1, right? So let's call this our integral here, a. And so here we have I will be equal to 1 minus a, right? Okay, so what is our a? Our a is equal to the integral from 0 to 1 of square root of 1 minus x squared dx. So at this point, let us make this nice substitution. We're going to let x squared equals y. So here, if you want to solve for x here, in terms of y, we have x is equal to root of y, right? So over here, let us differentiate both sides. So we have here 2x dx, right? Derivative of x squared is 2x dx. Then this is equal to the derivative of y here is just 1 times the y, which is the y. So here, let's solve for dx. So divide both sides by 2x. So this 2x cancel this 2x. So this implies that dx is equal to dy divided by 2x. Remember, x is equal to root of y, right? So we're going to have 2 times root of y. So our limit will remain the same, right? If x is equal to 0, y is equal to 0. And if x is equal to 1, y is equal to 1 square, which is 1. So from here, a is equal to the integral from 0 to 1. So this will become square root of 1 minus x squared is y, right? So this is y times the x is the y over 2 root y. So now we can change the variable, and that will not affect the question. So let's put out the 1 over 2. So we have 1 over 2 times the integral from 0 to 1. So here, 1 over root y is same as y to the power of negative 1 over 2. So let's write it as x to the power of negative 1 over 2. Then multiply by root of 1 minus y will be 1 minus y to the power of 1 over 2. So remember, we're changing variables. So 1 minus x to the power of 1 over 2. Then dx. Okay, now let us recall this famous beta function, right? So we know the beta of n is equal to the integral from 0 to 1 of x to the power of n minus 1 multiplied by 1 minus x to the power of n minus 1 dx. And again, we have the relationship between the beta function and the gamma function, which is equal to the gamma of m multiplied by the gamma of n divided by the gamma of m plus n. And again, we have this nice identity that the gamma of 1 over 2 is equal to square root of pi. And therefore, the gamma of 3 all over 2 will be equal to square root of pi divided by 2. Okay, so let's proceed. So here, a will be equal to, now, the power of x here, we need to write it as something minus 1. And the power of 1 minus x here, we need to write it as something minus 1. So here we have this 1 over 2, the integral from 0 to 1. So that will be x to the power of, we know 1 over 2 minus 1 is negative 1 over 2, right? So we have 1 minus x here. And we know 3 over 2 minus 1 is equal to 1 over 2 dx. So from here, this is equal to 1 over 2 times the beta of 1 over 2, comma, 3 over 2. So which is equal to 1 over 2, then multiply by gamma of 1 over 2, multiply by the gamma of 3 over 2, divided by the gamma of 1 over 2 plus 3 over 2. Right? So let's go ahead and simplify. So we have a is equal to 1 over 2 So gamma of 1 over 2 is square root of pi, multiplied by gamma of 3 over 2 is square root of pi over 2. Then divided by 1 over 2 plus 3 over 2 is 2. The gamma of 2 is equal to 2 minus 1 factorial. We know this. Gamma of n is equal to n minus 1 factorial, right? So therefore, gamma of 2 is equal to 2 minus 1 factorial, which is 1 factorial, which is 1. So here we have this over 1. So we can see from here, a is equal to 1 over 2 multiplied by square root of pi times square root of pi is pi, then divided by 2, which is equal to pi over 4. Now, let us recall that our integral I is equal to 1 minus a. From here, we have the right answer, that the given Berkeley Mathematics Tournament, that the value of that given integral is equal to 1 minus a, which is pi over 4. Amazing. Thank you for watching. Please kindly subscribe. You can turn on the notification button so that you'll be notified anytime I upload new videos. Please, if you find this video interesting about how to evaluate this kind of definite integrals or even the indefinite ones, if you're just familiar with this and you really need to learn more about how to evaluate integrals, please comment down below, because once I receive much comments, I will start uploading this kind of videos. Thank you for watching. Bye bye.